There's its formula, 12 minus x over 3. So this one here, number 77, yeah, it is a function of x. Yes, sir?
In this scenario, would 1/3 x plus 4, y equals 1/3 x plus 4 also be appropriate?
Minus 1/3 x plus 4, but yeah. Uh-huh. Yes, sir?
Every single one of those is a function of, or y is a function of x, because all of them can be put in that format that you just did.
Yeah, I think, yeah, these, in fact, the instructions say every single one of them you can solve for y, and then find f of 3. So like this one, f of 3 would be 12 minus 3, which is 9 over 3, which is 9 over 3, which is 3. So these problems not bad. Let's see here. So let's see if you guys can work this one. For 87, what is the largest interval over which this function is increasing? So there's minus 2, right? What does this arrow mean? Decrease. Right, so did I say increasing? I said increasing, right? So increasing basically from minus 2 to where? To 0. So from minus 2 to 0, it's increasing. Where is it decreasing?
Oh, from negative infinity.
Right, from negative infinity all the way to minus 2. That's what this arrow means. It means it goes on and on. We didn't have that in any example. Well, it was implicit within my example 1, 2, 3. Those all had graphs that went on and on, but the ones I drew next in example 4 and 5, those were not like that. Let's see here. This one's kind of funky because its domain would be all real numbers. See, because everything always goes somewhere, right? This is basically what you're looking at here is the round down function. It's like stupid rounding. You give me 1.9, and I round down to 1. You give me 1.99999, I round down to 1. Right? When you get to 2, I'll stay 2. 2.01 rounds down to 2. That's what this graph says. Like anything from 0 to 1, it outputs a 0. Once you get to 1, it outputs that. But when you get to 1.99999, it still outputs 1. So that's like, this one, the range for this function is just counting numbers, right? 1, 2, 3, 4, and well, also minuses. But,
so if you,
oh man, what the what?
Because it's like,
all right, let's go on here.
How would you do the range for that? Would you just have to do like all?
So this is what we should talk about for the remainder of the time today, guys. How about this here? These functions right here, what's this? What's going on here? What are these? Have you seen these before? Once? Do you remember these? Did they give you joy? No? So this is a case-wise defined function, right? So let's look at this one here. F of x is 2x for x less than minus 1. And f of x is x minus 1 if x is greater than minus 1. We're asked to calculate f of minus 5. What is it equal to? Let me write it down here. F of minus 5 equals to what? So the input minus 5, which case does that fit into? Is minus 5 larger than minus 1 or less than? It's less than minus 1, right? So I use the formula 2x. So I do 2 times minus 5, and the answer is minus 10. And what else I'm supposed to try f of minus 1, right? What would f of minus 1 be in this case? What's that? Less than or equal to. Oh, so it's still the same case, right? Still twice the input, yeah? 2 times minus 1 is equal to minus 2 then, right? And what else are we supposed to try? F of 0. F of 0, how would we do that one? Well, f of 0 definitely fits into what? Greater than negative 1. So we do 0 minus 1 for the formula, right? 0 minus 1. So the answer is minus 1. All right. So how do you graph a case-wise defined function? Let's look at one of those. So suppose I tell you f of x is equal to, let's say, x squared plus 1 for x greater than or equal to 0. And it's equal to 2 minus x for x less than 0. And then the instructions are graph y equals f of x. So here's my example. What example are we on? I don't know. 8, 9, whatever. So how would you graph this? What do you have to do? So here's the deal. What this means, right, is that y is x squared plus 1 for x greater than or equal to 0, right? And it means that y is 2 minus x for x less than 0. So we can graph both of those things, right? That's a line and a parabola. We know how to graph those, right? So it's a line with slope -1, and the y-intercept is what? It's what? What's the y-intercept here? 2, yep. So we got a y-intercept of 2 and a slope of -1. So slope -1, I think, looks something like this, right? And should this dot be open or closed? It should be open because that case has strict inequality. So that's an open dot. Then what else happens? So then we have a parabola with vertex 0, 1, right? So it is, you know, just it's only half of the parabola, though. It's this piece here, right? And that would be the graph of this case-wise defined function. To graph a case-wise defined function, you have to graph the cases separately, string them together. So now that we've done this, what's the range of this function? What's the domain? Yeah, the domain is everything. Very good. Yep, you're right. Because it doesn't matter, right? You may like, well, don't you have to exclude 2? What happens with 2, though? See, 2 is attained. The value y equals to 2 is reached right over here, right? When you plug in 1, f of 1 is 2, because 1 plus 1 squared is 2. So it does, you know, it does hit 2 over there. So, you know, try out these homework problems. If you can work them, then I think you understand case-wise defined functions pretty well, but you might have something to learn here, you know? Anyway, I will shut up. Have a good weekend, you guys.
Thank you.